Umaira and Alvin, please
Yes, sir.
start by talking to yourselves before you talk to us about 22A. We are listening.
Okay, so for A, it's p of x is equals to x minus 2, and then the answer is a 2 by 2 matrix, and then it's in the first row 0 0, second 4 minus 1.
I agree with that matrix. I got the same matrix as you.
Okay.
Umaira and Alvin, are you saying the final matrix is a 2 by 2 matrix with the entries in the first row being 0 and 0, in the second row being minus 4 and 1?
Yes,
No,
sir.
4 and minus 1, sir.
1 minus
Hmm?
1.
Sorry?
4 and minus 1. The
Oh,
second
positive
row.
4. Positive 4 and minus 1.
Yes, sir.
Okay, please talk to us, the two of you.
Okay, guys, do you all agree that it's a 2 by 2,
I
0 0 4 minus 1?
also agree.
I agree.
Agree.
I agree.
Hi, boy.
Okay. Alvin and Umaira, thank you. There seems to be oh no, not there seems to be. There is an agreement with what you found for number 22A. Please take us through number B. It's still with you.
All right. For B, is it fine if I go first, Myra?
Yes, go first.
Okay. So I got obviously a 2 by 2 matrix as my final matrix for 21B. And the matrix entries are in the first row 7 and 0,
Yeah.
and in the second row 20 and 8. Are we agreed?
I got 20 and 2.
Second row.
Mm-hmm.
Oof. I think we've got a bit of a disagreement there. So,
Talk to each other. Either you choose, any one of you. Umaira, you can either choose to go first to take us step by step on how you ended up getting the matrix that you have, or Elvin, you go first, but taking us step by step to arrive at the matrix that you say you found. Okay, before any one of you explains their matrix to us. Elvin, you said you have got this 2 by 2 matrix. The entries in the first row are 7 and 0. In the second row are 20 and 8.
yes, sir.
Umaira, you say the matrix that you have has got the entries in the first row 7 and 0, but in the second row you've got 20 and 2. Umaira?
Yes, sir.
Okay. Please ignore what I just said. What are the entries for your matrix?
7 0 22.
Okay, thank you. Now talk to the two of you. Talk to each other in terms of who will go first, then followed by who. The two of you. We need to see where and how this last entry ended up being different between the two of you. That's what we're interested in now.
Umaira, is it okay?
Yeah,
Sorry?
yeah, please go first, Alvin.
Okay, I'll go first. So, I started off with squaring.
Hang on, Elvin. Please everybody, let's pay attention to what Umaira and Alvin are saying so that we can be able to understand how they got to the final matrices. Thank you.
Okay. So in terms of squaring the matrix, my entries for that were 4, 0, 12, and 4. And then obviously at the end with the 1, you know that from what we learned yesterday, you could say that it's multiplied by an identity matrix. So I just converted it at the end to 1, 0, 0, and 1. So then I also proceeded to multiply the matrix which was squared. And for that entry, actually for that matrix, the entries were 8, 0, 24, and 8. Am I still with everyone?
Yes.
All right.
Yes.
And then I proceeded to subtracting and then adding. Actually, did it all in one step. So for the first entry, which will be 8 minus 2 plus 1, that would be 7. And then alongside it in the first row, it's 0 plus 0, 0 minus 0 plus 0, which is 0. And then second row, entry, it will be 24 minus 4 plus 0. That gives me 20. And then alongside it in the second row, 8 minus 1 plus 1, which is 8. And that's how I got the final matrix of 7 and 0, 20 and 8.
Thank you. Umaira,
Yes, sir.
did everybody follow Alvin's explanation of how he arrived at the final matrix? Hello?
Hi, sir.
Hello?
Hello. Can you hear me?
Yes.
Alvin, may I ask you a question?
Yes, ask away.
Your x squared. Please redo that for us. Walk us through that again.
Okay. So for x squared, I got 4
Yes.
and 0 in the first row.
Yes.
And then in the second row, I got 12 and 4.
All right. Please do me a favor. Please
Okay.
double check the entry for the second row, second column.
Second row, second column.
Please double check that entry for us.
All right.
Yes, it's supposed to be 1.
Yes.
Yeah. I think for that one, I used the wrong entries to multiply with each other.
So instead, I think, because I think you got an 8, right?
Yes, I did.
If I'm not mistaken, and I stand to be corrected, and on my error, please comment, but I think it's supposed to be a 1.
Yes, I got a 1.
Thank you, ma'am. Thank you.
Thank you.
Thanks to you.
Yes. What are we saying now, Alvin?
So I guess I did like a silly mistake in terms of the multiplying the matrices for like squaring it. So I think instead of multiplying by 1, I multiplied by 0.
By 0.
By 0. That's for second row, second column.
I just need to get clarity from Alvin based on the engagement that he just had with Theo to say, what is he now saying to us? Alvin.
Yes, sir.
Mm-hmm. Are you saying to us then we should stick to your original matrix that you gave us with the entries 7, 0, 20, and 8, or what? Or are we changing? Or is this the final matrix?
No, we can change the matrix.
We change the matrix
Yes, sir.
to what?
To what Umaira got.
To what you might have got?
Yeah.
Umaira,
Yes, sir.
do you agree that Alvin can take over or can borrow your matrix?
Yes, sir.
Are you lending your matrix to Alvin?
Yes, sir.
Are you sure?
Yes, sir.
Okay. If you agree to lend your matrix to Alvin, then does everybody agrees with you on this matrix?
On my final answer, does everyone agree that the final answer is a 2 by 2 matrix 7, 0, 22?
I
I
agree.
agree. I agree.
Agree.
Okay.
Thank you, Umaira. Thank you, Alvin. Alvin, let me also thank Theo for coming on board to help in terms of taking you through or walking with you through those steps until you found where you made that mistake. Thank you, Theo. Thank you, Umaira. Thank you, Alvin. Before Alvin and Umaira, you are still on the floor. Let's talk to William. William,
I wanted to know which number are you on? I just joined now. I had technical problems.
is this the first workshop that you are just joining? You just joined.
Yes, it's the first one.
Okay, welcome.
Thank you, sir.
Yes. So you join us being in the process of verifying the answers for 22 A, B, and C. So Umaira and Alvin, okay, we agreed yesterday that 22 A, B, and C will be taken home as a homework.
Oh,
So we agreed that Humaira and Alvin will be the team that will lead us in providing us with the answers for 22 A, B, and C. Then we'll just be following them. And then double checking whether the answers that they found are actually those that we are indeed looking for or not.
okay, I get it, sir.
Now, they just told us that an answer for 22A is a 2 by 2 matrix with the following entries in the first row, 0 and 0. In the second row, 4 and -1. And then for 22B, the matrix that was found is a 2 by 2 matrix, has got the entries in the first row, 7, 0, 20, and 2. Now the pair will come back again to share with us what they found for 22C. That's what we are busy with. Vincent.
But like I got like something. I get that like it matrix for A. I can they repeat like for A? I got 4 and 0, 4 and 3, which is 2 by 2.
For number 22A, ne?
22A, yeah.
In the first row,
Yeah, 4
let's
and
start.
0.
Let's start with 22A.
22A, yeah. I got 4.
Yes.
2 by 2
They got
matrix, and then I got 2 by 2 matrix with entry 4 and 0, 4, 0, and then 4 and 3. And then for B, I got a 7, 2 by 2 again, 7, 0, 20, and 2.
We agree with you on number B.
And then, yeah, and then this A,
That's where we disagree with you.
yeah, I can, like, I get maybe, like, I don't know. Maybe I did something wrong.
Okay. Let me request the members. Okay, let me request the members to attentively listen so that they can be able to help where you made a mistake or help in terms of what led to you not being able to get this same matrix that we all found, by allowing you to take us through all the steps that you went through to can be able to get to the final matrix that you have for number A. Please share with us that final matrix of yours.
Or should I share the steps or the final matrix?
Any.
Okay.
Please, members, please help. Which one will be easier for Vincent to can be able to follow?
Okay. Okay. My steps is this. Like, I took matrix A as since when it's x minus 2. And then
Hang on, Vincent. Hello. Hello.
Vincent?
yeah.
Yes.
Are you all here?
Yes. And he is 3.
Okay.
So we can.
Vincent, everybody is here. Please take us through step by step. Please, members, let's listen to each and every step of that Vincent is going to share with us, and then interfere where we feel that he made what he was not supposed to make. Okay, Vincent, please share with us that final matrix of yours for number A. The entries are?
The entries are 4, 2 by the entries are 4, 0, 4, and 3.
Okay. Now please take us through the steps that led you to this final matrix.
All right. P of x is like x minus 2. And then I took like a P of A, and which is like A minus 2, and then 2i. A minus 2i. Then in the space of A, I put my matrix, which is 2, 0, 4, and 1. And then minus 2. And then into the identity matrix of 2 by 2 matrix, which is like a 1, 0, 0, 1. And then I multiply the 2, I distribute the 2, and then I on the identity matrix, and then I got negative 2, and then 0, and then 0, negative 2. Then I took it like I'm subtracting matrix A, and then A minus 2 times identity, then which is like a 2 minus 2, and then 2 minus into minus 2, and then which is plus 4 plus 2, then that's 4, and then 0 minus 0, that's 0, and then 4 minus 0, that's 4, 1 minus 2, and then which is 1 plus 2, and then which is 3. That's all.
Okay, can you repeat again, please? After
All right.
multiplying by negative 2.
And then after multiplying by -2, I got like the matrix change, and then it became -2, 0, and then 0, -2. Is there something wrong?
Yeah,
Sorry?
so after that you minus matrix A with that matrix, new matrix, which is -2 and 0 and 0 and -2.
Yeah.
So meaning you said 2 minus -2.
Yeah.
2 minus -2. That's all. I think that's the problem. Actually, you had to multiply by only 2, not that side with the sign -2. You have to multiply by only 2. So meaning your new matrix is gonna be +4, not +4, +2, 0, and +2.
Oh. By the way, the problem is sign. Wow.
So now you see your mistake.
Yeah, it's the sign, like the sign. The
Yeah,
way I did it, I should have like changed this negative sign and then plus, because I've already distributed the negative sign inside. So, yeah.
yeah. You
And then
hold. Yeah,
which means
that
like
huh?
the negative sign in between is gonna be a plus, which means like it's gonna be 2 minus 2, which is gonna be 0.
No.
2 plus
That
-2. Yeah.
that minus in between, it's a subtraction.
All right.
So meaning you have to say matrix A, which is 2041, minus matrix the new matrix, which is 2002. Not when you multiply by -2,
And then
subtract
the matrix is gonna be
the final matrix.
0.
The final matrix, I knew you're gonna say 2 minus 2 is gonna be 0.
It's gonna be 0. It's gonna be 0, 0, ne?
Yes.
The final matrix is gonna be 0, 0, ne? And then 4.
Yes.
And then -1. Am I right?
1 minus 1 is 0. Oh, 1 minus 2 is -1. Yes, you are correct.
Okay.
Guys, you agree with us? Oh. I was not here.
Lebo, can I just say something?
Yes.
Okay. Even if Vincent multiplied the matrix with -2, if you multiply, if you decide to multiply with the -2, which means now you're no longer subtracting, you are now adding the two matrices.
You are now adding 2. So if this guy multiply with -2, are you aware we no longer having sign? So we are going to multiply 2 matrices.
No, you'll be having a plus sign if you multiply. If you decide to use the negative sign, you'll be now left with the positive sign, which means you'll now be adding the two matrices.
Yeah, if you say so, if you are if you are going to put a positive, it's gonna be correct, because 2 plus minus 2 is 0. Yeah, it's gonna be correct.
Yeah, so you even if you had multiplied with the -2, you are supposed to then add after. If add the two matrices, not subtract.
Yes, that's the mistake. After multiply by -2, you subtracted.
Yeah,
you used instead of positive.
Yes.
Yeah, I don't know if
Now I understand. No, thanks, guys.
Level.
oh yeah. Ebo.
Thanks.
Sorry.
Yes.
Level, if you can just explain to me.
Magwena.
Okay.
Yeah, please hang on. Let me. You will come. Ne? You are next on the line. Ne? You are next on the line.
Okay.
Can I
All
please
right.
talk to Vincent? Then you will follow. That was
Right.
Mike and Lebona, as well as Vincent.
Yeah.
Yes.
Vincent, did you follow what Lebo and Mike were saying?
Yeah, I did. I did get a hang of it. My problem was just a sign, like I used a negative sign twice, and then instead of like changing the outside, like and then supposed to be positive.
I mean, during the engagement, or based on what they said, were you able to trace what you were not supposed to do, but you ended up doing?
I traced what they told me, like, yeah, and then I did understand the problem. Like, where was my problem?
Will you be able to fix it?
Yeah, I fixed it, and then I got the right answer.
Okay. Thank you, Lebo. Thank you, Mike. Thank you, Vincent. Magwena, please come in.
I just wanted to know, how did they find the new matrix? The new matrix that they're subtracting from the matrix that were given.
Magwena.
Okay.
Yes. Before, I think I'm also confused. I'm also confused with your question. Before we throw your question at them, may I please also try to understand your question? What is your question?
Okay. My question is, Akira Lebu Are, they subtracting the new matrix from the given matrix. I want to know, Akira, we are supposed to compute P of A. So P of A, if we're computing P of A, then I just put the entries where I see A. So I want to know, how did they approach this? Because I wasn't here yesterday. I had a problem.
Yeah, if I'm understanding your question, Namakun, you are saying is x minus 2. Anja. So for x, we substitute matrix A, 22, not 21. You see 22, A is equals to something.
Oh, 20, okay.
Yes, and then after that, for minus 2.
For what?
For minus 2. Yes, that one. And then minus 2. And for that 2, we have to multiply that 2 with identity matrix for us to have matrix subtracting matrix, not matrix subtracting A. Can I be something? There's
Constant
2.
or a number.
A scalar.
Constant. Yeah, constant. Now you understand.
I understand.
Yeah, you can try it now and then you see what you get.
Thank you, Lebu.
Yeah, so every time where you see a constant, you multiply that constant with an identity matrix, because identity matrix is equals to 1.
Lebu.
Hello?
Lebu. It's not every time. It's when you do polynomials. It's not every time.
From my understanding, I can say it's every time. Because even if you prove something, we multiply by I, which is, we know I is identity, is multiplied by 1. So it doesn't change anything.
If you're not doing polynomials, you don't multiply by I.
Okay.
I agree with Lebu because multiplying by an identity matrix is the same thing as multiplying by 1. So what she's saying is solid in this particular case because we are dealing with polynomials. If you want to convert a constant or a number into a matrix, then you multiply it by an identity matrix so that it takes the shape or the form of a matrix, even though it's the same as multiplying by 1 in a way.
That's what I'm trying to say.
I concur, Mr.
Oh,
Abdul and Lebu. I concur.
You
Wait.
concur,
Kenji.
I concur. Yes, sir, man.
you are going to know English. I want to come. Serious.
Boss. Nice.
Thank God.
Magwena. Okay, okay. Magwena.
Yes, sir.
Magwena.
Yes, sir.
Did the explanation that was provided to you help you?
Yes, it was helpful.
Are you sure?
Yes.
Are you now in a position to can be able to handle these kind of questions?
Yes.
Okay. Do you still remember who shared the valuable information with you amongst us? Just a few seconds ago, a few minutes ago. Who provided the clarity?
Can you please rephrase your question?
Do you still remember who provided you with that guidance on how to can be able to solve these kind of questions or exercises? A few seconds ago.
Yes.
Do you still remember them?
Level.
Alone.
The matrix is the new matrix is.
Okay, let me just say what I need to say. May you please just say a word of appreciation to the people who just shared the valuable information that now guides you on how to handle exercises such as number 22, A, B, and C.
It was Levo, Vincent, and Elvin, if I'm not mistaken.
My request, just thank them, or in simple terms.
Thank you. Thank you, guys.
No, you're welcome.
Thank you all. Thank you all. It's important.
Okay, thank you.
It's important, Magwena. We
But
are here for
I did thank.
Yes, I heard you. It's important. We are here for each other. We are also here for you. Okay.
Yes.
Thank you. Now, Umaira and Alvin, we are still in your capable hands for number C. Please share with us what you found for number 22C.
All right. So, without further ado, I got my final matrix, which is obviously 2 by 2, with entries. In the first row, 5 and 0, and in the second row, 20 and -2. Are you agreed?
My second row is 20 and 0.
Alvin, you say your matrix, your final matrix is a 2 by 2 In the
Yeah.
first row, you've got 5 and 0. In the second row, you've got 20 and minus 2.
Yes, sir.
And Humaira, what do you have?
5 and 0, 20 and 0.
Yes. Please,
Is
Alvin,
is this for number B or C?
C.
number C level. Alvin, please take us through each and every step that led to this matrix. And then you will be followed by Humaira, who will then explain to us how she ended up having a 0 in the last entry.
Okay.
Before we can talk to other members.
All right, sir.
Other members, please check your steps so that we can be able to advise Humaira and Alvin on their different answer for the last entry. Okay.
We got from B the squared matrix is 4, 0, 12, and 1. And then I took that squared matrix and I times it by another matrix of A to get the cubed of that matrix. So I times it by 2, 0, 4, 1. So it was, so I got my final matrix x cubed to be 8, 0, 28, and 1.
Okay.
Then I subtracted it from 2x, and then I set 2 times the matrix A, so, and I got 4, 0, 8, and 2. Then I added 1. So because 1 is not a 2 by 2, I multiplied 1 by its identity, which is 1001.
Yeah.
So x cubed minus 2x, the final matrix for those two combined is 4 and 4, 0, 20, and minus 1. And then that matrix plus 1, 0, 0, 1. The final matrix is 4 plus 1 is 5, then 0 plus 0 is 0, 20 plus 0 is 20, minus 1 plus 1 is 0. So it's 5, 0, 20, and 0.
Agree.
Agree. Thank you, man.
Yeah, siyavuma. Yebo, that's true.
Ah, what a beautiful
What's the
explanation.
final matrix?
Thank you, Humaira, and thank you, other family members. Now,
Sir,
let's give, we are not yet there. Yes, someone called me.
what's the final matrix of
We are
my
final matrix. We are not yet there. We now need to, we are now going to request Elvin to share with us how he ended up having the matrix that he has, in which himself and Humaira differ on the last entry. Other family members already agreed with Humaira's matrix, where the last entry is a 0. But now we are interested in understanding. I'm requesting you to pay attention, each and every detail that Alvin is going to share with us so that we can be able to concur or share with him where he might have gone the road that he should not have taken. Alvin, please go ahead.
All right. So I actually did everything Humaira did. It's just the final step that was a bit of an issue in terms of the adding and subtracting. So instead of adding the 1, I actually subtracted. That's where I went wrong in terms of the final matrix.
Mm-hmm.
Because like for the final, for the final row, the second row, second column. The problem was I was supposed to add the 1 to -2 so I can get -1, which plus 1, which added to 1 would be 0. I instead subtracted the 1. I said -1 minus 2. So that's where I went wrong. I made a silly mistake in that step.
Or are you now saying you are changing your final entry from -2 to 0?
Yes, sir. I'm changing my entry. I'm changing the matrix rather.
Are you sure that you should have done something to make that final entry to be 0?
Yes, sir.
Okay. If that is the case, let me thank Humaira and Alvin for leading us on these questions. Now, to come back to answering Lerado. Lerado, then that means that we agree that the final matrix for 22C is having the entries, is a 2 by 2 matrix. It has got the entries 5, 0, 20, and 0.
I disagree.
Yes, Lebo, go ahead.
I disagree, sir.
I hear you. Please go ahead. Just don't disagree.
Yeah,
Tell us why. What is it that was made? What is it that was made that was not supposed to have been made?
My final matrix is 2 by 2. It's positive 3, 0, 20, -1.
Positive 3, 20,
0.
0.
No, it's positive 3, 0. Give us a row, and then in second row.
Level.
Yes, sir.
Let's take it slowly. Is positive 3 in the first row.
Yes.
Second entry.
0.
0. Second row.
20.
20.
-1.
-1. Is this your final matrix?
Yes, sir.
Okay. Please take us through the steps that led you to this matrix. Please, everybody, let's listen to each and every detail that Lebo is sharing with us.
Yes, sir. My first thing I did, which is x cubed. Our question is x cubed minus 2x plus 1. And then for x cubed, I substituted a matrix of 2, 0, 4, and 1, which means I have 3 matrices that I have to multiply. But I first multiply 2 matrices, which is 2, 0, 4, 1, and then in 2, 0, 4, 1. So maybe multiply those 2 matrices, I got 4, 0, 12, 1. And then after that, I multiply that matrix with 2, 0, 4, 1. So meaning I multiply matrix 4, 0, 12, and 1 with matrix 2, 0, 4, and 1. And then after that, I got 8, 0, 28, and 1. And then after that, for 2x, I substituted where I see x, 2 matrix of 2, 0, 4, and 1. And then so I have to multiply that 2 throughout, which I got positive 4, 0, positive 8, and positive 2. And then for 1, I substituted identity. For my identity is 1, 0, 0, and 1. So for now, my equation that is in matrix form is for first matrix is 8, 0, 28, 1 minus second matrix is 4, 0, 8, 2 plus third matrix is 1, 0, 0, 1. And then I used BODMAS, which I have to add before subtraction. So I add matrix 4, 0, 8, 2 with 1, 0, with matrix 1, 0, 0, 1. So I got 5, 0, 8, 2. And then in that matrix of 5, 0, 8, 2, I subtracted 8, 0, 28, 1. Okay. Before I got my final matrix, I subtracted 8, 0, 28, 1 with 5, 0, 8, 2. And then that's where I got 0, not 0, 3, 0, 20, and negative 1. Guys, I don't know if I did something wrong somewhere. Can anyone please correct me or agree with me?
All right.
Oh, okay. No, you can go,
Okay,
Vincent.
Vincent, can I help?
Yeah, please do.
Even though, like you said, you use BODMAS and then you add first. Am I correct? All right.
Yes.
Okay. Let's leave the middle matrix because it's the minus sign, and then let's add like the first matrix, which is the positive, and the last matrix, which is like 8 plus 1 is 9.
Yes.
Am I right?
You are correct.
And then, okay. And then 28 plus 0 is still 28.
Yes.
And then 1 plus 1 is 2.
Yes.
Is 2.
Yes.
Which means now we are having our matrix like that. We are having 9 and then 0 and then 28 and 2.
Yes.
All right. Then let's subtract now. 9 minus 4
is 3.
9 minus 4 is 5.
9 minus 4. Okay.
9 minus 4. 9 minus 4. Now we are taking the middle matrix. Yeah, now we are taking the middle matrix, which was like with a negative sign. Now we are subtracting it from what we got, like from our addition, which was our yeah.
Yeah, 9 minus
9 minus 4
is 5.
Is what? 5, ne? That's
Correct.
the first entry, ne? Our final answer, our final matrix, that's the first entry, ne? And then we've got 0. You've got 0 minus 0, and then it's gonna give us 0. Are we still together?
We are still together, my man.
All right. And then from our addition, and then we just add like it was like 28. Our final matrix was 28, and then 28 minus 8
is 20.
Is 20, and then that's our second entry. Then we are left with the last entry, and then now we said like 1 plus 1 from the last from the BODMAS, which you said like 1 plus 1, and then minus 2, which was 1 plus 1, which is 2 minus 2, which is 0. Do you get a hint?
Okay, Vincent.
Yeah, level, Yebo.
Yes, I hear what you are saying and I see what you are saying. So now
Okay.
I'm incorrect for what I did. Am I incorrect? I want you to say yes or no.
The way you add, like just check your sign. You just corrected me like on the sign. Just check the sign, then you'll get you get the right message, which
So
everyone like have, which is 50.
so okay, by right, ne,
Mm.
I was subtracting, not adding, because that matrix
Exactly.
in the middle, it has a sign of negative. Anya,
Correct.
yeah,
Correct.
this tiny thing. So now I have to
Yeah.
see why is addition in front of a
Exactly.
Anya.
Exactly. That's why I said let's take like the first matrix and add with the last matrix because all of them are positive.
Oh, okay. Yeah. Another question. Yeah, thank you, man. I see my mistake. So now I want to ask, what if I didn't use a botmas? I started minusing first matrix with the second matrix, and after that I add that identity. Am I going to be incorrect?
It's still going to give you the same answer because like now, if you are subtracting it's 8 minus 4,
Mm-hmm.
and then which is 4,
Mm-hmm.
and then 4 plus 1 it's 5.
Oh yeah. Oh yeah, I see.
You see, and then there
Yes.
we've got 0 0 0. There we've got 0 plus 0 minus 0 plus 0 is still 0,
Mm-hmm.
and then there's 28 minus 8, which is 20.
Mm.
And then the last is like a 1 minus 2, which is negative 1 plus 1, which is 0.
Mm-hmm. Yeah, thank you.
All right.
Is it now clear in terms of what the answer should be?
Yeah, in terms of botmas.
Now, are you still sticking by your matrix that you gave me or not?
No, that's incorrect, sir. I'm sticking now with matrix 5020, which is correct. That one.
Now, let's go to question number 37. Okay, this is what I'm actually interested in us talking about. Not in fact talking about solving. We are told that in exercises 37 to 38, determine whether A is invertible. And if so, find the inverse. In exercises 37 to 38, determine whether A invertible. And if so, find the inverse. Are we all clued up in terms of handling this question?
So which question are we at?
Number 37. You see 37?
Oh yeah, I see it
We
now.
are here. In fact, we are here because we are going to deal with these two, 37 and 38. Can you see my screen, Lerato?
Yes, I can see.
Yeah.
Yes. So 37 and 38. My question is everybody clear?
So what's X?
No. Hang on, Lerato. Okay, Lerato. Okay, let me keep quiet. Please talk to them, Lerato. Ask them whether they all understand what is it that they need to do or not. Ask them.
Guys, do you understand what you need to do in question 37 and 38 or not?
We also don't know what's X.
X is a matrix that you're supposed to find.
Mm.
Like A, it's matrix A. I, it's the identity matrix of A. X is what is the inverse of A if A is invertible.
Okay.
Can you now confidently be able to handle number 7?
Yes, sir. I can try.
Okay, thank you. Lerado, it looks like it was only Umaira who had a challenge.
I have a challenge also, sir.
Lebzan.
Is it Lerado? Or is it Levo?
It's Leb.
Levo,
Sir, I have a challenge. Yes, sir. I don't
you
know
have a
how to.
challenge.
Yes, sir. Determine whether A is invertible. I understand that one.
Mhm.
If I'll find the inverse, okay, I have to find the inverse. Now they say hint. Why they are giving us this hint? That's my
find the
question. Lerato, please help.
Okay. A hint is solve AX is equal to I for X pi, equating corresponding entries of the two sides. So solve AX is equal to I. A is the matrix that we are given. And then X, it's the inverse if it exists. And then I, it's the identity matrix of A. If A is a 10 by 10, I is a 10 by 10 identity matrix. That's what I'm basically saying. You solve for X, substitute, solve for X. That's why the hint is there.
Yo, I saw for X. Now for my side, when I see find the inverse, what's on my head is I have to find the determinant number 1.
Oh.
Yeah. That's why now I'm confused. So now usually why they are giving us this hint, meaning this hint is something else.
No, man. This is the 3 by 2 matrix, so you cannot use 1 over determinant times adjoint matrix. Because the 3 by 3.
Actually, you do. The methodology is very similar. You just calculate the adjoint differently. This formula doesn't change.
Yes.
It's to find the inverse of a matrix. To find the inverse of a
It's
matrix, it's still 1 over the determinant multiplied by the adjoint. The only difference is how we calculate the adjoint for the 3 by 3.
But it seems like this time around we don't use that equation. I can say that formula, because
Yes, it's
I saw
different.
something, like when there are 2 methods to find the inverse. Is that of the formula of 1 over determinant multiplied the adjoint, and the one is for you equate I, and then you do what echelon form, what something like that. You choose
row operations.
row operation. So we are doing row operation here or not?
We are doing that here.
Yes, you are.
We are doing row operation.
Yes.
Yes.
Or no?
Yes.
Yes, you are. And just to add on to that, Lebune, you will also have to have, like it's if they call it an augmented matrix or what. On one side, you're gonna have this matrix that you are given as A. And then on the other side, you're gonna have an identity matrix. And then you need to perform your row operations so that the identity matrix that was on the right is now transferred onto the left. And then once that operation is done and your identity has moved from the right to the left, whatever you will have now on the right will be the inverse of whatever you started with.
Okay,
One
so now,
understand?
yeah, so now I'm going to say this matrix A is equals to the identity of that matrix.
So
And then
why wanna this? Look at this matrix that you have, EG37, ne? And then instead of having a bracket, you will have a dotted line in between. And then on the right-hand side of it, you will have an identity matrix. A is not an identity matrix. There are some row operations that have been performed on an identity matrix for it to give you this A. So now we have to undo those operations that have been done to the identity matrix. That's why we are introducing it. Hence, even our formula has an identity matrix as well. So you will have this A on your left, and on the right, you will have an identity matrix. You know how it looks like 1, 0, 0, 0, 1, 0, 0, 0, 1 with that main diagonal with ones only. And then you'll make sure what is on the right, which is an identity, you try and transfer it to the left by using your reduced row echelon or your however you do that, but make sure that your identity moves from the right to the left. And when that operation is now successful, whatever that you will have on the left will be the inverse of what you started with.
yeah, I understand. Yeah, I ran away from this method. Now it's getting me. Oh.
Well, it's convenient because this one, it will help you with bigger matrices. You know,
Yeah.
it's easier to deal with when it comes to bigger matrices.
Yeah, thank
Level,
you so much. Yes, sir.
level.
Yes, sir.
Is it clear now on how you need to wear your techies and get on the racetrack?
Yes,
Okay, you thought there was a shortcut, eh?
No.
Huh? You thought there was a shortcut to the finish line.
Yeah, I wanted to go to shortcut because I know if they say that if I see that AX is equals to I know this thing it's a what I have to do a lot of work. So,
Unfortunately, my sister.
And traumatize this equation.
Okay. In other words, what Abdul is saying, we are all okay. Was it only Lebo who didn't understand how to get started? Or first it was Umaira, then Lerato helped. Then second was Lebo. Was it only Lebo and Umaira? Okay. That means Umaira and Lebo, you are the only two who actually had challenges in terms of solving this exercise. Let me add to what Abdul said. You've got the matrix, the given matrix, alongside, on the right-hand side, you've got an identity. You will solve the matrix on the left-hand side using row operations until you have got an identity on the left-hand side. I just said what Abdul said differently, but saying the very same thing. I hope I didn't confuse anybody, ne? Umaira, you still follow what Lerado said, ne? Lebu, you still follow what Abdul said, ne?
Yes, sir, but now I'm stuck because I can't remember what I have to do, but I will see my older books and try to do it.
Reduce the row echelon form. That will be an identity. Then whatever that you'll be having on the other side will be an inverse.
Sir.
Okay, sir.
Sir.
Yes, Lerato.
37 and 38.
Yeah.
I'm
Okay.
done.
Okay. Magwena, then let's go with what you found. What did you get, my sister?
My final matrix is on first row I got half, half, negative half. Second row I got negative half,
Hey,
half,
whoa,
half.
whoa, whoa. Hey, Magwena, hey, this bus. This bus will cause a big accident. Okay, first row. What is
I
the
got
size of the matrix?
3 by 3 matrix.
Thank you, my sister. You said the first entry is a half, the second one is a half, the third one?
It's negative half.
Negative half. Okay, now we are going to the second row.
It's negative half,
Negative half,
half and half.
half and half.
Yes.
Last row,
It's half, negative half, half.
half, negative half, and positive half.
Yes.
Now let me bring in Abdul, followed by Gia. Abdul.
Yes, sir. Now my final
What?
matrix. It states that my matrix is invertible, and the inverse of this matrix is first row. It's a 3 by 3. The first row we have 1, -1, and -1. And then second row we have -1, 2, and 1. And then third row we have 0, 1, and 1.
Let me repeat. You said first row you have got 1, -1, and -1. Ne?
Correct.
Second row, -1, 2, and 1.
Correct.
Third row, 0, 1, 1.
Correct.
Thanks, brother. Kia.
I got first row. It's a 3 by 3 matrix as well.
Mm-hmm.
Yes. And for my first row, I got -half, -half,
Mm-hmm.
and
Mm-hmm.
0.
Mm-hmm.
No, -half, positive half, and 0. Second row, I got.
Let's start. First row, what do you have?
First row is -half,
Mm-hmm.
half, and 0.
Positive half.
Yes, positive half.
Okay. And 0.
And 0.
Yes. Mm-hmm. Second row.
Second row, it's -half,
Mm-hmm.
positive half, and 1.
Mm-hmm.
Third row, it's positive half, negative half, and 0.
Lerato.
Yes, Lerato.
Oh, the matrix A,
yes,
it's non-singular. And
okay.
X is a 3 by 3.
Thank you.
X is a 3 by 3. It has +1, -1, -1 first row. Second row,
Okay.
-1, +2, +1. Third row, 0, +1, +1.
I love you must teach us this your English, my man. You are strong, you.
Thank you, Lerato. Now let me. It looks like there are people that
I'm stuck somewhere where I have to find 0 for position 3 of row 1.
Okay, keep going.
Yes, sir.
Theo,
Yes.
welcome back.
Yes, sir.
Do you need our assistance, Level?
I really need assistance.
Oh,
Yeah, I will
welcome
request
back to you.
you. I will request you.
Okay, welcome back to okay, welcome back to
Yes,
you,
sometime.
Nelebo.
Lala is there. Bongani is there.
Okay, now let me go back to Bongani. Bongani, what did you get, my brother?
Yeah, me, I got a lot of halves here. So.
Yes, We need them. At the end, they will give us a loaf of bread.
Yeah, so yes, they will give us a loaf of bread. So okay, the size of the final matrix is 3 by 3 matrix, right? So I'm
Thank
having
you.
half for my first entry. My second entry is half, and then my on the first row, the third entry is negative half, and
Okay.
then I have negative half, half, half. Then I have half, negative half, and half. That's it. That's why I'm saying it's a lot of halves.
That's Bongani.
Yes, that's Bongani.
Okay. Yukia and Magwena. Hey, yeah, you've got many halves. Now,
Hello,
Lebo,
sir.
I didn't forget
Sorry.
about you. We are still
Sorry,
going to
sir.
come back to you, ne?
Sorry, sir.
Yes.
Someone is talking. Someone called me.
Yeah, it's Mike talking.
Yes, Mike.
Yeah, now my answer is the same as Bongani.
So, Mike, you say your matrix is similar to this one that Bongani just gave us.
Yes, but I think maybe afterwards I can explain because I think I've got a different method that I used or yeah.
Because up to so far, Bongani, Mike, and Makwena have got the same matrix. But now, let me talk to, okay, I've got two,
Vincent.
Vincent, yes. What is happening? Okay, let me come here. Hey, then I'll be able to see everybody.
I got something.
Yes, Vincent. Yes, what did you get, brother?
I got something else. I'm not even sure. I got like
Yes,
the first row.
we need that something else.
The first row I got 1
Mhm.
0 0,
Mhm.
and then the second row I got negative 1 1 0,
Mhm.
and then the third row I got half, negative half, and half.
Thank you, brother. I
The
need to
third
make
row
sure
is the
that
same as us.
Yeah,
I need to make sure that I don't leave anyone out. Vincent. Okay. Alvin.
Yes, sir.
I'm requesting your matrix. Your final matrix.
Okay. My matrix is obviously 3 by 3, and it has the entries in the first row 0, 1, and negative 1. Second row negative 1, 1, 0. And then in the third row, it's 1, negative 1, and 1.
Thank you. Sure. Yeah. Now, let me look at what I've captured here. So, Lorado, yes.
It's Lerato. I think
Yes,
I might.
brother.
I think this makes me sad, but I agree with the halves because
Yes.
Agree.
That's the spirit.
I recalculated it again, and I got half, negative half first row.
Hang on, Lorado. Now we are changing the matrix that you gave me, ne?
Yes.
Okay, now I want to change your matrix from the initial one to what you are giving me, then I'll go back to Levo and Theo. Okay, what did you get, brother?
Half, negative half first row.
Half, half, negative half.
Yes.
Second row.
Negative half, positive half, positive half. Third row, positive half, negative half, positive half.
The same matrix as Makwena
And Bongani.
Bongani and Mike.
Yes.
4 people have got the same matrix. Let's talk to Lebohang, and okay, Lebo is stuck, and then she specifically requested Theo for help. Lebo?
Yes, sir.
Okay. I've captured how many answers here? Let's say 1, 2, 3, 4. 4 people have got the same answer. Abdul's answer is different. Kia's answer is different. Vincent's answer is different. Alvin has got a different answer. Humaira is still working. Now, please talk to us in terms of where you are stuck. And then, but before we bring in Theo. Theo?
Yes, sir.
Are you finished, my brother?
I'm done. I've checked my answer 3 times and I am ready to give it. I'm also ready to explain it to Lebo.
Okay. Please give us your matrix. Then
all right.
Yes, first give us your matrix before you talk to Lebo.
Ladies and gentlemen, my final matrix is a 3x3 matrix, and in the first row we've got positive half, and negative half. In the second row we've got negative half, and positive half, and in the third row we've got positive half, negative half, and positive half.
Thank you, Theo. Now, Theo, Makwena, Lerato, Bongani, and Mike have got the same matrix. 2, 3, 4, 5. 5 people have got the same matrix. Now, Lebo.
Yes, sir.
Please share with us your problem, and then as you specifically requested Theo to help out, then Theo will come on board to help. Then we are all with you.
Okay, guys, listen what I have done, and please correct me. And you, Theo.
Yes. Oh, Lebo, can I
listen.
tell you what I'm going to do? So I'm going to make it easy for me and you. So remember how you said you wanted to do your matrix using the adjoint method from the 2x2 matrix? Because clearly you are like me, you don't like using row operations to get the inverse like the other guys did, because I'm assuming Mr. Abdul did it via the row operations where you multiply the matrix you multiply it with the identity 3x3 matrix. I'll show you a different way, but what I'll do is, after you've told us what you did, I'll post my solution and then I'll teach you my method step by step. And I think you'll find it easier.
Yes, please.
Yes, ma'am. Perfect. Okay, so before we do the teaching thing together where we teach each other how to do this, walk us through what you did so that we can have a handle over where you are with the situation.
You reminded me something. So what I have to do now is to take a picture while I'm explaining, so you can see what I have done.
Yes, ma'am. Yes, ma'am.
Hey. Done.
All right. I'll have a look just now.
Guys, you can check on the chat what I have sent. That's where I've stuck. So now, first thing I have done is for row 1, I see that I have a leading one. So now I don't have to manipulate anything there. So I go to row 2.
Oh,
so for
please hold for 2 seconds now. Please hold for 2 seconds. Mr. Abdul.
Sure, Theo.
Can we ask for a big favor from you? Because I know you know this method well. I'm not well versed in this method. So please comment on what Lebu did so that we can follow what she's doing, because I'm not that well versed in this method. And then I'll explain my method to her later. Please help us here.
Okay, no problem.
Thank you, sir.
Okay, so now I'm talking to Mr. who?
Mr. Abdul.
Hello, Mr. Abdul. Yeah, okay, what I've done, you know. Yeah, so I for row 2, I minus row 2.
Okay, I can't hear you properly, Lebu. Can you speak up a bit? I'm not sure if it's your line or something.
For row 2.
Yeah, row 2.
When I'm working with the row 2 minus row 1.
Row 2 minus row 1.
Yes. You see
Yes,
what
Level.
Yes, I agree.
Sorry. Hang on, please. Level.
Yes, sir.
Can you please make it simple for all of us to can be able to follow? I think this was a request that was made in another workshop of ours, so that we can all follow and be able to participate and then be able to help.
Yeah, I must speak English, I know.
Yes, please.
Yeah, people, all of you guys, can you see on the chat?
Yes, ma'am.
Hey, so for row 2, I said row 2 minus row 1. That's what I've got. At the bottom, it's 1 0 1 0 0 1 1. Okay. I will start with first row. First row is 1 0 1 1 0. And then second row is 0 0 1 negative 1 0. And then third row is 0 1 1 0 0 1.
Can you start? Can you repeat your second row, please, again?
Do you see on the chat?
Well, I'm listening to what you're saying. I just want to make sure. Can you repeat your second row?
It's 0 0 1 negative 1 0.
0 0 negative 1 0.
Yes.
Okay, let me follow through, because I was trying to also trace my steps and yours. So sure you followed a different procedure. I'll look at your solution here.
Yeah, please.
Okay.
See my
Yeah,
solution
okay,
on the chat.
Okay, yes, go ahead.
And then in last row is 0 1 0 0 1. And then after that, I wanted to find row 2. For me to get for me to guys, do you see my working thing?
Okay,
can you
so in terms of your solution, can I try and lead you step by step in terms of what I think you should have done? So you spoke about having the leading pivot on your first row, right? Which is 1 0 1. Can you see that? You have 1 already in that row. And then the rows below that, the second row has 1, and our aim is to change that 1 into a 0.
Yes.
And then in the middle, we are not planning to change that 1, so it will stay the same. We're on the second row. And then on the third row, we need to change the second entry of the third row for us to try and reduce it into an identity matrix. So for what you said, you said for row 2, you were gonna say row 2 minus row 1, which I agree with. And when you perform that operation, your row 2 will now read 0, 1, and 0.
0, 1, and 0.
Yes.
Why? Why? Because I'm subtracting row 2 into row 1. Yeah.
And you are changing row 2. That's what you are doing. Bear in mind, you are working on row 2. That's what you are changing, right? So if you multiply
Yes, I'm
row
working
1,
on row 2.
yes. So if we multiply row 1 by a negative and we add it to row 2, you'll have negative 1 plus 1 is 0. So your first entry for the second row is going to be 0. Do you agree with me?
I agree with you.
Okay, sharp. And then we move on to the second entry. 0 can't be negative. So 0 plus 1 is 1. So second entry, second row is 1. Do you agree?
Mamela, from my original name.
Yes, we're talking about the original now. Original, from the original one. So you do agree with me that now second row, second entry is 1 based on the operation we just did. Lebu.
You hear me?
Lebu.
Well, you can't have breaking, but can you hear me now?
Yeah, because like there's something, network, what?
Okay,
yeah,
fine.
we can hear you, Lebu.
Yeah,
can I continue?
Listen. For entry, for second entry, on row
Which
2.
row? Second row, yes.
Yeah, second row. Second entry. So I have to say 0 minus 0 because it's row 2 minus row 1.
Hence, I said we are starting afresh. The top, those matrix that you wrote in red, I'm working from there now, trying to show you because from your workings, for the mere fact that you didn't have a leading 1 on your second row, for me, I couldn't take that solution based on that. So remember, in an identity matrix, it's like for every row, you will have a leading 1, and then below there's a 0 leading 1 on the second entry, then 0, 0, 1. I hope you understand what I'm trying to say.
I do understand. Yeah, there's something happening there. I see my
So hence I'm
mistake.
saying now the operations that I'm doing, I'm starting from scratch. The main matrix that was given to us, the one that we are multiplying by the identity. We said what we are doing is we are changing row 2. And us changing row 2, what we did, we're going to multiply row 1 by negative and add it to row 2. So if we multiply row 1 by negative, you will have negative 1 plus 1 is 0.
Yes.
So now you agree on that, ne?
Yes.
And then we move on to the second entry of the first row with the second entry of the second row. 0 plus 1 is 1. You agree?
Yes.
Okay, fine. And then we move on to the third entry. Negative 1 plus 0 is negative 1. Do you agree?
Yes.
Fine. And then you go on to your identity matrix. You also do the same. Negative 1 times 1 is 1. You agree? And negative 1. Do you agree? And then negative 1 plus 0 is still negative 1. It doesn't change. So I'm on the other side of your identity matrix. The operations that we did was on the main matrix given to you. Now we are working on the identity matrix that you introduced.
Okay.
So with your main identity matrix, you have for the first row 1, 0, 0, and then for your second row you have 0, 1, 0. So what you did on that matrix, you have to also follow the same procedures in terms of the first row and the second row. And we said you multiply the first row with a negative, and then you add it onto the second row. So minus 1 multiplied by minus 1 is minus 1. and then -1 plus 0 is -1. Do you agree? So now, second row, first entry of your identity matrix must be -1.
I'm lost now. I'm lost. Hello.
You have two matrices, Lebo.
Mm-hmm.
You have the original one that was given to you.
Yes.
And then you have the identity matrix that you introduced.
Mm-hmm.
So when you work on these are like, it becomes more of like one bigger matrix, but we've separated it in the middle so that you can follow what is going on. So far what we've been doing, we were working on the original, we were performing row operations on the original matrix. So now we are on the identity, because what you do on the left, you also do on the right.
Yes. So can you please repeat or like you are minusing row what into row what and which row?
It's still the same concept of first row multiplied by -1 and you add it onto the second row, because we are working on the second row.
Okay, you said for second row you multiply -1 by.
Do you understand why I multiplied by -1?
So can you repeat that? Like
okay.
-1 multiplied by row what?
-1 multiplied by row 1. And why am I multiplying by -1? Because with your main matrix that's given to you, the first and the second row have the leading ones. And your goal is to try and reduce it into irreduced row echelon form. We are trying to reduce the first matrix, the original matrix, into reduced row echelon form. That's what we are doing. So whatever operations that we perform on the main matrix, you must also perform on your identity matrix that you also introduced.
Yes.
Are you following?
I'm following.
So for the first original one, I multiplied by -1 because I want the other row to be negative, so that -1 plus 1 gives me 0. That's why I multiplied the first row with the negative, so that when I add the negative row to the second row, it gives me 0.
Okay. Why can't you leave that one as 1, the leading one? Because for our identity, we have a leading one, which is 1, not -1.
So what I want you to focus on, we are focusing on the original matrix. Your identity is just for you to keep track. Your identity is also just there to reproduce your inverse that you are looking for. The main matrix that you are trying to get into reduced row echelon form is your original matrix. The identity one is just there to give you what your inverse will be after you've reduced the main.
All right, so first step, I multiply row 1 with -1.
Yes, and then you add it to row 2. And by doing that, you are only changing row 2. That's what you need to be aware of. Row 1 is not affected.
Okay,
we are changing row 2.
Yeah, listen, sorry for interrupt. You wrote what you are saying to me right now. You are explaining to me.
Yes. And then say, in the meantime, while I'm also doing this, can I also take this opportunity to explain, okay, or try and account for my working out, and then the colleagues will also do the same on their side.
Yes, you post, then you explain.
Okay, yeah. Now, based on what I've sent, guys, so as you can see, on the left, I have the original matrix that was given to us, and on the right, I have an identity matrix.
Yes, sir.
And with these row operations that you guys are seeing on the left, that's what I'm actually doing, so that you can follow in terms of how did it move from that matrix to whatever matrix it is moving to.
Question. So essentially, if I may ask,
yeah,
for anybody who might not be clued up, what you're trying to do here basically is convert the matrix on the left to look like the matrix, to become the identity matrix, basically. And
Correct.
then what's gone then, once you've converted the matrix on the left to the identity, the matrix on your right
Is the inverse.
Yeah. Yes. Yes, I get you. Thank
Yes,
you.
it's exactly like that.
So based on that, everyone can see this? And is there anyone who would probably have a question in terms of what I've done then? But so far, even with these operations that I've written on the side, firstly, from my first original matrix, for me to get to the second one, I said row 2 is the same as negative row 2 plus row 1. I just did what I was telling Ulebu. And then from the first matrix, you can see that the one that I had on the second row has turned into a 0. So I'm reducing it or turning it into reduced row echelon form. And then for row 3, I said row 2 plus row 3. Having added that also, it gave me a 0. And then for row 2 now, and I'm trying to, with this row 2 equals to negative row 2, I'm now multiplying row 2 with a negative to make this one in the middle positive.
Okay.
And then it came out to be positive. And when I change this side, whatever also is on that other side also is going to be affected by that negative. So if you look at the other side, the first entry on the second row was 1. But on the next step, that entry is now negative 1. So it's like I'm treating these two different matrices as one bigger one, but I've separated them in the middle so that I can track which matrix is changing and what I'm doing.
Okay.
And then having done all those row operations, you can see now that what is on the left is the identity matrix, which was on the right. And now what is on the right is now said to be the inverse of whatever matrix I started with. So I can say this is an account of how I got to my final inverse matrix, which is 1, negative 1, negative 1 for the first row, and negative 1, 2, 1 for the second row, 0, 1, and 1 for the third row.
Okay.
So can you also follow on your side?
Yes,
do,
so
my brother.
you didn't show all the steps, right?
Those row operations that I've done there, those are the steps.
Okay.
Mr. Abdul, much appreciated. Honestly. Thank you.
Yes.
Thank you so much for this, dude. Really appreciate.
We are.
Okay.
And now, guys, I know that there are other colleagues who also got halves. Can I kindly request that you guys also share your solutions and then let me see if I've done a mistake on my side. Where is it that I've gone wrong so that I can retrace and fix as well?
Okay, so do we question to the family? So do we get the other colleagues to share their solutions first so that we can see how they got their halves, or do I jump in then show Lebu how I did it because I did it completely differently?
Okay, before that you can
Okay,
jump into.
may I
Must
please come in?
Yes, please.
Yes.
Vincent, I do note your hand. Ne? Now, let me request Lebo and Theo to continue. And then after that, we'll take Vincent, and then after Vincent, then we'll have a way forward.
Okay. Lebo, are you ready?
Yes, sir. Send your
Okay.
picture, please.
So a little disclaimer now. I think this way is easier, but it might be slightly longer, but it's easy to follow. And I think you'll prefer this because you remember you wanted to work with the iJoint.
Yes, but they said for this question, I'm not supposed to use iJoint.
Guess what? You can, and I'm about to prove it. Are you ready? Oh, you can.
I can. Okay.
Yes. Yes. You must just stay with me and pay attention, but it's very easy. Okay. Have you guys, I've sent it. Can you guys see it? It's 2 pages.
Yes, I see.
Okay. Are you ready?
I'm ready.
Cool. Let's do this. Okay. So right at the beginning by step 1, you see I said determinant. as we can agree, you know the matrix that we've been given is 1, 0, 1, 1, 1, 0, and 0, 1, 1, right?
Mm-hmm.
Okay, do you know how to calculate the determinant of a 3 by 3 matrix?
Yes.
Okay, as you can see, I calculated there, and you can see the determinant is 2, right?
Yes.
And because we know the determinant is 2, we know that the matrix is invertible. Can we agree on that?
Mm-hmm. Yes.
And basically the formula from what we were doing with the 2 by 2s, remember when you calculate the inverse is, I even wrote it there, I said the A inverse is equals to 1 over the determinant, and determinant is 2, right? Multiplied by the adjoint.
Oh, yes.
Cool. Now I'm going to show you how to work everything else using determinants to get the answer. As you can see there, I said step 2, and with step 2, I said determinant of minus. Can you see that?
Yes.
Okay, so what we're going to do is we are basically going to calculate small determinants for each value in the matrix. So as you can see, we've got 9 entries in the matrix, so we're going to calculate 9 small determinants. And as you can see, you see I've written there R1 for row 1, R2 for row 2, and R3 for row 3.
Mm-hmm.
Okay, so cool. So if you calculate the first determinant for the first entry in the first row, if you cover that 1, you are left with then 1, 0, 0, 1. Can we agree?
Yes.
And then we calculate the determinant for that. And then you do the same thing. So we start from the top, we start from the beginning, and we move to the right. So we first do the first entry in the first row, second entry in the first row, like that and like that. And as you can see, I wrote down all the mini matrices and all the determinants for them. Do you follow?
I follow.
So it's the same method we've been doing all along. It's just that we first calculate the big determinant for the whole matrix, and then we calculate all the determinant for the minors. We call them minors. This method is called, I think, the minor and cofactor expansion method or something. But yeah, and as you can see in the end, we've got our new 9 entries. You see them, right?
Mm-hmm.
Row 1, row 2, row 3. Great. And then now we're calculating the adjoint, the one that you and I wanted. You basically take those all those values and you put them in a matrix. And as you can see, I put it there underneath where you can see it's the new matrix is then 1 minus 1. It's then for row 1, it's 1, 1, 1. For row 2, it's minus 1, 1, and 1. And for row 3, it's negative 1, negative 1, 1, right?
Yes.
Are you still with me?
I'm still with you.
Are you following me completely?
I'm following completely.
I'm so glad. Okay, we're almost done. Home run time. Let's do this. So now we've got our new matrix as you see it there. And then we've got to basically multiply our matrix by what you see next to it, which is basically, remember when you calculate the determinant, you alternate the signs where it's plus, minus, plus, minus, plus, minus.
Mm-hmm.
So you multiply that new matrix with the signs, with the plus, minus signs, and then you get the matrix next to it. You see that, right?
I see.
So our positive 1 stays as positive 1, or the next one becomes a negative, the next one becomes a positive, by alternating the signs. Just be careful where if you've got a situation like in the third row, first column, you can see that negative 1 gets multiplied by positive and it becomes negative. So it's one of those things where we must just make sure that our arithmetic is correct. Fine?
Yeah, so
yeah. So now we've got our new matrix, we've multiplied with the signs, we've got.
Hello?
Sorry? Yes.
Yeah, so determinant of minus, you're trying to find cofactor matrix.
Yes, that's what we're doing. Literally, that's what we're doing. It's cofactor expansion and minus, yes.
Mm-hmm. And then after that, where you multiply by signs, you were trying to find the adjoint of.
Yes, now we're calculating the adjoint. Yes, that's it. That's exactly it, Levo. Yes.
Yeah, you see, this method, I mastered this method, you know?
Yes.
Yes, this one is the shortcut method. That's what Minel said. It's shortcut method.
Yes, but anyway, can we? Because the question just asked us to calculate the inverse.
Yes.
Yeah, but anyway, can we finish off so that we can get commentary from the other guys?
Let's finish.
Okay, so where we basically are, for anybody who might not know, we are at the end of the last page, but the matrix above that matrix at the bottom, right?
Mm-hmm.
Where we've got the plus 1, minus 1, plus 1, and so on. So what we do with that matrix then is we transpose it.
Yes.
As you can see at the bottom, I transpose the matrix, and then we move to the second page. So now we've got, remember the determinant we calculated in the beginning?
Mm-hmm.
So it's 1 over the determinant, which is 1 over 2, right?
Yes.
And then it's multiplied by the adjoint, which we worked out just now, right?
Mm-hmm.
Then boom, Bob's your uncle. There's your matrix at the bottom. There's your inverse. easy like that?
Yeah, this one. It's very easy.
It's quick. It just has steps, and you
And
must just remember the steps, but it's easy.
And imnandi this one.
Yes.
So now the one of row reduction, that's the problem.
Yeah.
And I think from the start whereby I was saying I don't understand what's going on, they explained to me that I don't have to take this shortcut. This method, they say it's a shortcut method. So they wanted us to do the row reduction method.
No, okay, yeah. But I mean, if for situations where we are told calculate the inverse, literally for calculating the inverse, there's like 5 different ways you can do this thing. That's the thing with matrices and maths in general. You can do one thing in so many different ways.
Yes. So now, sir, Mr. Glenn.
Yes.
Can you please?
I'm listening, my sister.
Yes, can you please clarify the question again? What we were supposed to do actually? We were supposed to do. We were supposed to find inverse in different in different ways, or we were giving instruction on how to find it.
Makwena has a hand up.
Before Makwena, let's bring in Vincent. Oh, okay. Before I bring in Vincent and Makwena, let me finish with you, Level. Level, what are you saying in simple terms?
Oh, can I say? Oh, okay. Sorry.
Yeah, in simple terms, they chose for us to use a method, or we have to choose any method. We have to use any method we want.
In this question, they don't exactly tell us how we must do it. They just ask us if it's invertible, 1, and 2. If it is invertible, find the inverse. They don't tell us which method we have to use. If you read that,
Did you get that, Level?
Yes, because the hint is not an implication of a rule that must be enforced. It's just saying should you be lost, you can try look for it in this way. So for this instance, for 37 and 38, we can find the inverse using the method that we've just done together now.
Oh, okay.
Yes, ma'am. Definitely, ma'am.
So, Menya, which one is the shortest method? Is this one the one that Theo was explaining?
From where I'm sitting, I don't know. From where I'm sitting, I don't know which one will be the shortest for you, because we are different. I don't. You have to choose the one that you prefer yourself.
So can I comment?
You were saying there's shortcut. Yes. Which one is shortcut method?
Can I tell you which one is the shortcut method?
Mm-hmm.
The shortcut method is the one in which you can get to the right answer in the quickest way. Because the thing is, and again, it goes back to what we spoke about in the other lecture where I was saying to Lerato, where I was saying, sometimes you can do something and it looks like a shortcut, but it takes you longer than it should to do. In that case, it doesn't really help you. Where you could have done something, you could have done half a page, but it took you 20 minutes. Or you could have done 2 pages, but it took you 2 minutes. So the one looks like it's longer, but it's actually shorter for you. So the shortcut is actually the one that gets you to the answer in the quickest and most accurate way.
Yes, Theo. You see your method, ne?
Yes, ma'am.
I mastered that method.
Yes.
So I thought they are saying now we have to do the row reduction method.
No,
that's why I start.
You see, if they say find the inverse and they don't explicitly state which method they want you to use, then you use the method that works for you. It's like remember on the calculus assignment that we had, where the guy said, find derivative using first principles. And then the second question was saying, find the derivative and use whatever method.
Yeah.
So if they don't explicitly state the method they want you to use the one that works for you. And in this case, for 37 and 38, it's not exactly stated which method you must use, but they hint in terms of what you can do. Then for 37 and 38, we can go and use the in inverted commas, the shortcut method. If you don't want to do row reduction.
Yeah, thank you, Theo. Thank you. Yeah, so sir, what I'm asking again is, are they going to, they might, the possibility are they are going to choose for us which method we are supposed to use on exam, or are they going to ask for determined and not determined inverse? So we are going to use any method.
It will depend on, okay, to answer your question level appropriately. It will depend on the instruction from the examiner.
And it's possible for them to choose for us.
Anything is possible, my sister, but the most important thing is to follow the instruction from the examiner.
Okay.
Okay, I'm going to come back to you. Did you understand the guidance, the discussion that was provided to you in terms of how to get to an answer by Theo and the others?
Yes, by Theo.
By Theo. Are you comfortable?
And then, yes, I'm comfortable, sir. For the other guy, who's this guy?
Mr. Abdul.
Whoa. Before you go to the next question, before you ask me another question. Please thank Theo for having provided the explanation that he provided to you.
Thank you so much, Theo.
Ma'am, anytime.
There was also Abdul in the picture.
Yes.
I'm requesting you to do the very same thing.
Abdul, I also thank you.
But Mr. Abdul, thank you too.
But I still need a clarification and guidance for this method.
No problem. As long as we are still here, we will help you. Now, Level.
Yes, sir.
Okay. Anyone, please help me out. From this section, the next one that we are moving to is the one that is dealing with elementary matrices, né? Am I?
Yes, sir.
Am I in line?
Done with chapter 1. There's no more elementary matrices after here.
Elementary.
No, is there no longer that section that deals with elementary matrices in your syllabus?
After here, we go to determinants.
No, there is elementary matrices.
It is elementary matrix.
Where?
Okay, thank you. Now, I just needed a confirmation of that. So, Level, you and I, when we get there, we must not fight. I did understand the explanation, the guidance that Theo provided to you. But please, remember, I'm warning you now.
You are all right.
I'm not warning you. I'm not warning you. I'm asking you now, so that when we get there, we don't fight. Okay? Yes. As long as you did understand the explanation that was provided to you in terms of getting an answer, I haven't got any problem, as long as you get the correct answer that we are looking for. But in the next section, please, let there be no tension between you and I. Né?
Okay, sir.
Then I know exactly where that tension might come. Please, let it not arise. Okay?
Yes, sir.
Thank you. Now, before I go to any other person, Vince, let's talk to Vincent, then followed by Magwena. Vincent. let's remind each other tomorrow at the beginning.
Yes, sir.
Let's hope that Vincent will be here as well as Magwena. Before we can start, may we please ask them what they needed to share with us before we start with anything.
Yes, and we must also, when you start the lesson, if it's okay with you, so we must just take stock with everybody and make sure that we are all on the same page regarding how to calculate this matrix, because we never actually ended up agreeing on an answer.
I agree with you. Now, there are 5 people with the same matrix.
Okay.
And then Lebo and Humaira still need to work on their matrices. Lebo?
Yes,
Lebo,
sir.
please
Yes, sir.
go restart the calculations. Humaira, wherever you are, please restart and work on this matrix. Alvin, please rework on your matrix. Vincent, please rework on your matrix. Abdul, Kia, please, including these 5 people who got the very same matrix, please just double check.
Yes, sir.
Tomorrow when we start, we'll talk to Magwena. We'll talk to Magwena and Vincent to hear what they needed to share with us, and then we will double check our answer for number 37, and then let me request you to take number 38 home as a homework. So what we'll do, we'll double check number 37 tomorrow to make sure that all of us have got the same answer. We will also double check number 38, which I'm requesting you to take home as a homework. Is that fair?
Yes, sir. Let us take number 38 down. Please wait for 2 seconds. Don't stop sharing your screen.
Okay.
1 1 1 1 0 0 0 1 1. Thank you.
Thanks. Did everybody copy number 38?
Yes, sir.
Yes, sir.
Is there an agreement on a way forward for tomorrow?
Yes, sir.
Yes, there's an.
If there is an agreement, then we agree that tomorrow then we'll wrap up this section. Then from there, then we'll start to talk about the next section that deals with elementary matrices.
Yeah, say for it's for everyone who is here. For those who just want the textbook to this the textbook that we are using, I think they can just send me an email and I'll be glad to just send them the textbook.
Sure. Can we have your
Thank you,
email,
Mike.
please?
Thank
So,
you,
Mr.
Mike.
Pramai,
Please
please
do.
throw that your email on the chat, in the group chat there, so that we can email you.
Yes, please.
Thanks.
Or I can help. He can email it to me, and I'll make it easier for you guys and forward it to you. I can also help
Even better.
because I've
Yeah.
got all the
Perfect.
email addresses. Mike, you can email it to me, Dikele Dinyanga, and then I will forward it to them. It will be easier.
Thank you so
Oh,
much,
okay.
man.
All right.
I'll just email it to you.
Thank
That
you,
will
Mike.
be much easier. Thank you for helping out, boss.